So do all of you have a Tinkercad account?
I have a school one, but not a home one.
I got removed.
I have
Me
a school
too.
one.
I don't have one.
No. I have one in my school.
No, I don't have one.
Okay.
I don't have one.
Okay, so in the chat, I'll put in the link. Could you all go to the link and then make a login with your account, like your email account or your parents' email account, and then remember your username and then the login? Because for today, we're going to use Tinkercad circuits to program an LED and light it up with an Arduino. While you log in, I'll just explain what an Arduino is. Is the link working?
I tried searching it up and it doesn't work.
It doesn't work. Like you can't click on it and go to Tinkercad, but if you copy it and paste it in your browser, it works.
Okay. So does anyone know what an Arduino is? Yeah, could you explain it in your terms? You log in with your own account. You can create one. Just go to the link and I'll say sign up. Yeah.
How do you make the account?
Go to tinkercad.com and then there's a sign up button at the top. I'll show you. Okay, can you see my screen?
Yes.
Yes.
Okay, so this is me logged out. Like right here, it says sign up, and then you can just create a personal account and then sign up with an email or whichever ones that fit you. Does that make sense?
Yes.
Okay. Can you all give me a thumbs up when you're done?
Is it login or sign up?
If you already have a login, log in. But if you have to sign up, sign up. Like if it's a new account and you haven't made one, then sign up. there shouldn't be a code you have to type because you're logging in through your personal account. Like okay. You just click this one, create a personal account. And then sign up with an email or this one. Yay.
I need my parents to approve it.
Can you repeat that?
I need my parents to approve it and they're not here.
Oh.
Yeah, it says for me that you have to check in their email, and when you do, it just says you have to approve, but it says you have to get an Autodesk account for free to get it approved. So I don't get that.
Oh.
I just put mine in so that I could go to my Gmail and approve it, but it
Yeah.
hasn't yet, so I'm just gonna check.
'Cause for me, it just says you have to make it Autodesk thing card account, Tinkercad account.
Oh. Could you try using your personal account?
Uh,
Like not your parents?
okay.
You could also use your school account too. Okay, so I'll talk about the Arduino. So this is an Arduino. To have design. I have to log back in. Okay.
I'm not ready yet.
It's okay if you're not ready yet. I won't start programming or wiring anything. I'll just show you what an Arduino is. Okay. So an Arduino. Um, rid of these. Can you all see my screen?
Yes.
Yeah.
Okay. Okay, so this is when you control a robot. This is how you can Arduino with just a controller. A microcontroller is pretty much your brain of the robot. It controls everything you program on the Arduino to make something move. For today, we're just going to do what's on the schedule, what's an Arduino, light up an LED, and a Tinkercad simulator. Um, for the whole duration of this class, we're doing everything on Tinkercad and another simulator, and we'll make other projects too. So you won't actually build an actual robot, but you'll do more of the software and the programming side of robotics. So this is an Arduino. Um, these are the can you see all? Can you all see my cursor?
Yes.
Okay, So these are all the black pins that you plug in the wires to. These are power. These are analog. The analog in and the digital PWM pulse width modulation. We'll all use these pins to light up an LED, make a piano, make a little game by the end of the class. And we'll all do this with the Arduino. These are GPIO pins, like the black pins with the holes. They're just pins for input and output. When you program, you always have to have an input. Like if you connect an LED, what pin is it going into? That pin, you have to put that in your code, and then you have to simulate that code, and then the LED will turn on. Have any of you used an Arduino before?
No.
Okay.
The one I use isn't exactly an Arduino, but it had like circuit wires and stuff.
Okay. Is everyone ready for me to start for the wiring of the Arduino?
Can you wait for a second? I'm not
Yeah.
yet.
Okay.
Same.
When you log in, so I have to wait.
I have a question.
Go ahead.
Are you gonna like provide a code, like a class code, because like for the account?
No, there's no class code.
Okay, thanks.
So once you're logged in, it should look like this. Share. Once you're logged in, it should be like this, but you won't have any of the circuits or 3D designs.
It says that my account has not been verified.
Are you using your parents' account?
I'm using mine.
Go to your Gmail and then see if you received any emails from Tinkercad that you need to approve.
Okay.
It's okay if you don't get Tinkercad working, because we're only using Tinkercad for today. For the other classes, we're going to use a different simulator.
Can I use my parents' account?
Yeah, whatever works best.
There's nothing in my account for if I take a cat.
Yeah, you haven't made any projects, so it won't have any. You won't have any.
Okay. But I checked in my account if mine's is verified, and it says that my account has not been verified yet.
Is there like a button where it says verify here?
No.
Uh, um, this is your own account, right?
Yes.
Okay. Do you want to share your screen if you want to?
No.
Can you say that again?
Oh no, I don't want to share my screen.
Okay, okay. Try using, is that your personal or your school account?
Personal.
Try using your school account if you have access to the email.
Oh, it doesn't have access.
Oh, okay.
I tried both ways. It doesn't work.
Try using your parents if you can.
Okay, I could try.
Arnav, is this where I go to? The screen I have, click on that. Like the screen I have right now. You should be all on the same screen. Okay.
Okay, I'm in, but now it doesn't tell me where to go. I'm confused now. Yeah, I think I can share my screen, I think.
Do you want to share your screen?
Sure.
Okay, I'll stop sharing.
Okay.
At the bottom, it just says share, and then you click a window to share your screen.
Okay. Where does it say at the bottom? Oh, where does it say at the bottom? It doesn't say share screen.
Okay, so right now,
I think you can just like I think you can just like remove the share screen, that you can just and I can just tell who I am, and you can like do access to share the screen.
can you repeat that?
Okay, so I can tell my name in the chat, and then you can just look at that person, and then you can like then you can just take out your screen share, and then you can
Okay,
screen
okay.
share me so that I can share my screen.
Uh, yeah, Arnav, do you want to share your screen?
What?
So it says you can all share your screen without me approving it. It's okay. If you can't send in, it's okay. Um, I'll just show you today for today, but then starting tomorrow, I'll send in a link and then you can all be ready with the link and sign in with the simulator. We use a different simulator tomorrow. This one was just a practice and it's block code, so it's really easy to learn. For like all of the ones that all the people that couldn't sign in, you can just watch for today and then sign in later when your parents help.
But I can share my screen so that you can just check where I am.
Yeah, but when I stop sharing, like I stopped sharing right now, you can all share and then it would work. Because I think you can share your screen. I don't have like there's no block. You can all share your screen. Because I stopped sharing. Okay, so we'll start again. I won't be looking at the chat, so if you have any questions, just unmute yourself. Okay, so this is Tinkercad. If you if you go to designs and then go to circuits, then you at the top it should say create with a plus sign. And then click on circuits. Is everyone on this page?
Yes.
Okay.
Yes.
Okay, so now go to the search bar and then type Arduino if you can't find the Arduino. Arduino Uno R3 and then drop it in. So this is the start simulator button and then this is the code. Once you add parts into it, this block code starts to change. If I go back, or you could also go to text. Um, but we're just gonna do block code for today. Ananya, can you
Can you
repeat
go
that?
back a little bit?
Like go slower.
Can you go back a little bit?
Uh, like that.
Yeah.
You click create and then circuits. Does that make sense?
Yes.
Okay. And then for the next one, type LED and resistor. I already have them at the top, but an LED is just a light emitting diode. It's like more like a switch, but it lights up whenever you connect it. And then a resistor is, so can you all guess another word for resistor?
I know. It resists stuff.
Yeah, nice guess. So a resistor, another word is just resistance. So resisting something in a circuit is probably resisting current. An LED, it has a certain voltage that you have to run into a circuit. So the Arduino, it runs with a certain voltage, 3.3 volts or 5 volts right here, the 3.3 volts or the 5 volts. For an LED, it has a specific voltage that if you power the LED right directly from the Arduino, it's gonna burn out and it's gonna not work. So the resistor, all it does is it limits the amount of current or the amount of electrons going into the LED so it won't burn out. That's why we need a resistor whenever we connect to an LED. Does that make sense?
Yeah, it makes sense for me.
Okay. So drag the LED and then oops, and then drag the resistor. So for an LED, there's two prongs. There's a cathode and an anode. So the cathode is the negative, it's the smaller one, and then the anode is the positive, and it has the little like turn in it. Like in a real LED, there's actually a short cathode, and then the anode's longer than the cathode. That's how you tell the difference between which one is positive and which one's negative. So once you click on the edges of the prongs, it gives you like a red highlight. Get the anode side and then connect it to terminal 2 of the resistor. And then say done when you're done.
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 Okay.
Okay.
Yay. So in the real world, what you would actually do is you would get a breadboard, which is this. Wait a minute. Okay. So this is a breadboard. These are all the pins. Like if I highlight them, all of these are inside connected to each other. So let's actually put this on a breadboard. So here I connected these and so the LED would be on the breadboard in real life. And then if you highlight one of the rows, one of the columns, um, like all of them are highlighting, all 5 of them are highlighting, that just means that whatever you put on this line, on this row, on this column, it'll all be connected to each other. So if you put the same resistor in this row, that just means it's also connected to each other. So in real life, you use a breadboard to connect an LED and the resistor to the Arduino. Does that make sense?
It makes sense.
Okay. How many of you are caught up with me?
Wait,
I did.
do we need to get the breadboard like to put the light on?
Yeah, because it's more real life. Yay! Someone has a breadboard in real life. Oh, Syria, you have a breadboard in real life. Have you ever wired it?
I kind of did sometimes.
Yay! That's good. Once you're all done wiring the breadboard, the LED, and the resistor, can you all say you're done?
Done.
Okay.
Done.
Done.
Okay, we'll move on. So this is the LED, this is resistor. Okay, now we'll connect it to the Arduino. Oops. So this part, so you can pick any of these holes. These are just the pins, but they're all connected to each other. You see the green circles that are all connected to each other. That just means that under the breadboard, there's like a metal plate that's connected to each of the prongs. So any of these 4 prongs that you choose, it'll connect to the Arduino. So I chose, this is the cathode. So I would go this way. Every time you click on it, you can make a turn. So this one goes to ground. And then ground is usually black. And then you do the same thing for the resistor on the positive side. We'll connect it to 13. So, and then this should be red since voltage is red. Could you all say you're done when you connect the negative and the positive to the Arduino? We connect this to 13 because it's digital. You can also do analog, but we're just gonna do digital since it's closest to the ground.
Done.
Yay.
Done.
Okay. So usually this is the USB. Um, this is this this is the connector port that goes to your computer when you're uploading code to the Arduino. Um, And this one is just for the battery pack. When you're done, the best part about using an Arduino is once you upload the code, you could unplug the Arduino from your computer and then connect the battery to it. And every time the code runs, every time you connect the battery to it, that code whatever code you put in the last time, that's the code that repeats itself whenever you whenever you give the Arduino power. So it's kind of like just like a robot itself because you give it a task, you program a task, and then it'll run for how many times you tell it to run. Like if you put your code in a loop, it will run forever, while loops. So that's the best part about Arduino. Once you power it, it'll run by itself. But right now we don't have enough battery, but we usually connect it with a 9-volt battery. So everyone's done with this part, right? Oh,
Yes.
Okay, Kanishka, what question do you have?
What I would like to know what type of robot we're
So, okay. Can you all see my screen?
Yeah.
Can you all see this purple?
Yeah.
Okay, so I sent this a few days ago. We're not gonna we can build a robot if you want, but once we're all done with these projects, I think these projects are cooler than building a robot. We built a robot last year. Because building a robot requires a lot of materials, and not everyone finished the robot within the time. We had a lot of time last year, and like only 2 or 3 people finished it out of the 14, 20 people. So I thought maybe if it went all digital, we all could do the projects, like a mini piano or a ping pong game on the Arduino. You could actually build these in real life with the materials. Like these are all materials you can buy online and actually make this circuit. It's just more easier to show. What's your question?
My question is, I don't have an account yet because like I'm still working to get it. So are we gonna do this like another time too? So
We can do it tomorrow too.
okay.
But don't worry about for today because we're only using Tinkercad for today. Starting tomorrow, we use a different simulator, and I'll send the link in the WhatsApp group where all of you can sign up before class starts next Tuesday, and then you'll all be prepared, and then we could all do the same projects. Like the piano, I think is the coolest one, but we'll also make a ping pong game, like the actual pong game, but just digital. Nisha, what's your question?
Can we know what robot you guys built last year?
Yeah, I can send in. I made a YouTube playlist, and then the last video shows you what robot we built last year, because we needed a lot of parts from last year. I'll just send you the link later today.
Okay, thank you.
Any more questions? Okay, so then we'll start the coding. The coding's pretty simple since we're doing block code for today. Starting tomorrow, we'll make an actual program with typing with rate
How do
type.
coding blocks on the side?
Okay, so there's this little code button at the top. Can you see it?
Oh, I see it.
Yeah, just click on
Yeah.
whenever you drop things in it, like the uh the interface would automatically add the LED, the resistor to it. You don't program a resistor, so there's no resistor in it. Okay, so do all of you have this? All of this blocks on your interface?
Yes.
Okay,
Yes.
so we connected this to the LED to the pin 13. So go to set pin 0 to high. Drag this block and then put it right here. And then since we're connected to pin 13, set it to 13. Setting this to high just means turning on the LED. If it's low, like right here, it just means turning it off. Can you mute yourself? Okay, so set pin 13 to high just means you're going to turn on the LED. If you run the code, start simulation, it should turn on. Does it all turn on and blink for 1 second? Since it said wait 1 second, it turns on and off every 1 second.
Yeah.
Yay! So
Yes.
this is how you turn on an LED using an Arduino. It's pretty simple. You could change the times. You could add more LEDs to make a rainbow pattern or like a Christmas pattern. So if I were to change it to 10 seconds, every time you change the code, it'll automatically stop. Ten seconds is too slow. Does everyone have this? What's your question, Tanisha?
I just have a comment. It's just like the program Scratch where you have to put like the things in it. So I can really relate. Like, do you have to like code this? Like my question is, do you like have to use that to control like what you want, like the light color, etc.?
Yeah, not the light color. The light color is dependent on what LED you buy. Like, you can change the color of the LED to like white or like orange, green. The color, you can't program a color of an LED, but you can if it has multiple LEDs in the LED. But like just one LED you can't program. It's dependent on the LED that you buy.
Okay, thanks. And I have a question because I just got the account. So for the green dots, how do you like get them? The ones that you have on the side?
The green dots on the breadboard.
Yeah.
Once you like just hover your cursor over them, you get the green dots. And then you select one and then it'll drag out. So like you have to connect, just like click on one of them and it should work.
Okay, thanks. And how do you get the lines, like the black line? I mean, the wires.
So if you have to select like a port. Like if I can select D8, it'll select it. Oh, like if you get a piece, you can connect them to it. Does that make sense?
Yes, thank you.
You're welcome. Okay, so if you want to learn how this actually works, it's in C++. The Arduino runs on C++. You have to program it in C++. Have to restart. Okay, so if you go to code, it says blocks up here. You can do blocks plus text. It gives you a block, and then it gives you the text. This kind of helps me learn, because blocks are easier to learn. You just drag and drop. But let's say you add another LED. It's 10 a.m. Um, I won't leave. I'll keep on teaching until I'm done. But if you need to leave, you can leave. Are all of you staying?
Yeah.
Yay!
I'm saying.
Well, I have to leave because I'm going somewhere. So,
It's okay. Um, I could try recording and then put it on the WhatsApp too. Okay, it's okay. Okay, so let's add another LED. No. So if you went here, oh, this is the best part. Okay, not 1 minute. Okay, so let's add another LED. And then the best part about using this program, so we'll delete this. When we're trying to make another LED light up, delete the ground. Ground is just common, which what question do you have, Anita?
So, are we allowed to take notes?
Yeah.
So like we can remember?
Yeah.
Okay.
Okay, so whenever we're doing ground, we always connect it to this part, the negative. Like on the sides, the horizontal parts of the rows are all connected. Like the whole strip's connected. Because when you highlight one of them, all of them are circled. But on the columns, only five, only six, five, only five of them are highlighted. So these four rows are connected to each other, and all these columns are separately connected. The divider. So these are not connected to these. They're both separate. So delete the ground one and then turn this to black. Since we both need both of them to be negative, both LEDs need power. Both LEDs need ground. Also delete this one. And then drag in another resistor and then put it onto the red one. So this is black, meaning it's ground. Connect it to the negative terminal on the breadboard. And then this is also ground. Connect it to the negative terminal on the breadboard. And then these are all connected to each other. So this pin is connected to this pin, which means all of these are connected. Now you can just drag the last pin that's the closest to the breadboard and then connect it to ground. Like that. Does that make sense? Yay! Okay, so now ground will be connected to the red one and the green one, the green and red LEDs. Now we have to do the positive side. Go to red for the color, and then just do the same thing, but on this time, do it on the positive terminal. And then connect this one to 13. Can you all say done when you're done? Hello? Oh, ground. Oh, G and D means ground. G and D means ground, sorry. V means voltage. Like here it says 3.3 V, 5 V. That just means volts. If you would want to search it up. Does that answer your question or no? Okay. So we'll start going back to the code. So both of them, so we don't have to change the code for this because we didn't make any change on the Arduino itself. We're still connected to ground, we're still connected to digital pin 13. We only made changes on our circuit on the breadboard, but both LEDs are connected to pin 13. So we only have to program pin 13. So if you don't change any of the code, both of them will light up. I'll stop the simulation. 1 second wait there. So now both of them light up. So you can connect an infinite amount of LEDs and all of them will light up.
I have a question. Why doesn't that little exclamation mark come?
Let me see. If I go here, not this, but a low. It doesn't show up. Oh, it does. Okay. I can't. Can you select on it? The exclamation mark. Oh, it's probably because how fast the LED is blinking. 1 second is 1,000 milliseconds. So we usually don't put 1 second on there, but the program runs it slower. Tanishka,
My question is the wires, like the ones on the bottom, the ones that you have that connect to G and D and 13, like how do you get it there? Because mine isn't like going.
okay, so if I were to delete them, do you see my screen right now?
Yeah.
Okay, so this red square with the black border, click on it
Okay.
and then drag it to 13. Click on it again if you want to make turns. This is how I make turns. So undo. Click on it and then click on it again to make a turn and then click on 13. Like the black pin.
Okay. And how about for the red one?
That was the red one.
Oh, sorry. Mine is black.
Okay. Because this is the red terminal.
So if I make it red, then it'll glow?
Yeah.
Oh, mine's not glowing for some reason.
It's not dependent on the wire that it's gonna work.
What do you mean by that?
So the wires, they just help you tell which wire is which. Whenever you're connecting to ground, it's always black because there's no current in it. And then the red one, it's just red because they're just standards, but it also helps you know that this is voltage.
Mm-hmm.
So that's just the colors. The colors don't help. So if both of them are black, but your connections are all right, the program will still run. The colors are just to help you realize what where's the pins going, like where they're connected to.
Oh, then how do I make it glow though? Cause mine is like they're just like
Are
red.
Okay, are all your wires correct? Like, are they the same here?
They're not bent the exact same way you did, but they're just like a bit pointier and a bit crooked, but they still fit into the little black like hole thingies.
Okay, so I think your code is just wrong, because if all your connections are right, it's usually just the code. So go to code, and then everything should be like this.
Oh, I didn't have that.
Okay, yeah. So drag in all the parts. The blue ones are output and the orange ones are control. Just drag them out, and then that's it. And then it should work.
Is it alright if we can keep that so I can just like see it?
Yeah, I'll just keep it on here. So if I run it, both of them should work. Oh, so someone asked me about the exclamation marks. It's because these are not probably the correct resistors. You have to change the ohms. Yeah. So it's usually 320 ohms, kilo ohms. Stop simulation, start simulation. Let's. What is this? So it's usually 290 ohms. So if I go back, okay, so 290, this is kilo ohms. If I go here, 290, and then stop simulation, run simulation. It just showed up the error. If you change the resistance of the resistor, the warning signs, the exclamation marks will go away.
I have a question.
Yeah.
Since you know like all the circuit stuff, is this not knowing this knowledge like helpful for like fixing stuff like at your house and stuff?
Yeah. Yeah,
So
it is cool.
can you fix like electricity stuff?
No, you need to have like in your house that's connected, like the plug, the wall sockets. You can't fix those. No,
Oh.
you'll get into trouble. You need to have like some kind of license for that. But you can like fix a light bulb or something, or a battery.
Oh, that's cool.
Yeah. And Vita.
So if we like write notes on all of this and um and we like take these notes and we want to build like a cool robot, a LED robot, should we like just use those notes that you that the things that you told us now?
Yeah. I'll send you in a YouTube link that we made last year. It's more
Okay.
easier. And then you can also find all the parts online, like on
Okay.
Amazon. Yeah.
Okay.
Okay. Syria.
I have the parts at home, at what you're making. So can I make it in real life?
Yeah. Just be careful because you have to download Arduino. So you have to go to this website and then go to software and then downloads. And then based on whatever computer you have to download it and then program it. The program's this, you can copy the program. If you go to text and then continue, this is C++ code. You just copy this and then put it into the Arduino IDE, and then you can actually do it in real life. Sean?
So do we get like for this, like the exclamation marks, do we have to like make it go away?
No, it won't do anything.
Okay.
Yeah.
My bulb still isn't lighting up even after I put the same code you had.
Is it the same as this?
Let me see.
Okay, so I'm done for today. The next meeting's on Tuesday. Next Tuesday. I'll send in the YouTube link and then I'll also send in a different simulator that we're using, and you also need to sign in for that. So if we don't have to not get any more problems during the class, I'll send in the link right after this, and then you can all sign in and then also watch the YouTube videos if you want to make a real bot. Okay, that's it. Bye. Also, if you finished building this project, this LED, like the one we made on the screen, could you all take a snapshot and then send like show it to your parents so your parents can put it on WhatsApp? If you would please.
Okay.
Okay, that's it. Bye. Thank
Bye.
you.
Bye. Thank you. Bye.
Thank you.
Thank you.
Bye bye.
Thank you. Bye.
Tata, bye bye.
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 Bye.